across campus. There's a general interest in this kind of topic, which I think is nice to see. And, so without further ado.
Yes, so I'm very happy to be here. Oh, even beforehand, maybe rather afterwards. So thank you for having me. I'm very happy to be here and present to you some work done in my lab at Bielefeld University. And regarding my background, I'm a social psychologist, but I'm working together with colleagues at SciTech. And SciTech is an interdisciplinary center where about 270 researchers work together from multiple disciplines, like 15 disciplines are represented there, and linguists as well. And we're interested in how to make human-robot interaction smooth, acceptable, and what factors from the psychological perspective might drive this is something that interests me a lot among other lines of research which I pursue, because I'm not only doing robotics research but also attitude measurement, direct attitude measures, gender issues. But today I will talk to you only about research that interests me and where there some mutual interest might be. And this is regarding what makes people particularly human? So the humanization aspects, why do we attribute humanity to other humans and why might we deny this to others? And then on the other hand, and that might interest people here more, what makes robot particularly human? And of course I know that there are many experts on this here, but I want to bring a psychological perspective in, and I will show you a psychological framework that we have been using in the past years and we've been tackling experimentally to kind of understand more about all of this. And coming from the literature or coming from the research background on prejudice reduction and dehumanization, I want to first outline to you some aspects about what makes people particularly human. And the social psychological literature has studied this quite extensively. Jacques-Philippe Leyens from University of Louvain-la-Neuve, for instance, has done that quite a lot. And they have asked people, what makes people particularly human? And what people said was like, there's intelligence, language, and also emotions, feelings. And they then differentiate between primary and secondary emotions, or emotions that are reserved for humans only, as compared to emotions that can be experienced both by humans and by animals. So they use this distinction in their intergroup research, where they ask, for instance, to what extent do Germans have primary and secondary emotions? And people just had to tick a list and tell that. What you usually find in the intergroup context when you differentiate German versus New Zealanders or Dutch people or whatnot, or British against the French, you would always find that humanity is reserved to the in-group. So typically human secondary emotions like hope, admiration, as compared to primary emotions like happiness, anger, and so on, as compared to these emotions, they are reserved for the in-group only. So humanity essentially is reserved for those who belong to our group, whereas others are denied such humanity. So in this way, the attribution of emotions can be used as like a proxy for dehumanization as a very mild form, but regarding measurement issues, this could be quite informative for us as well. So there was a lot of research in that regard, and that's how I started out as well in the infrahumanization literature. But then there is not only the attribution or denial of emotion to humans or others, and we will speak about the robots later, but also there are personality traits that are deemed to be essentially human, and Jakob is working on this right now in his PhD. So Nick Haslam and colleagues, I'm just visiting their lab in Melbourne right now, and that made me also give me the chance to come here. They have been studying what are essentially human personality features, and they have proposed that there are two dimensions, human nature and human uniqueness. And if you deny people attributes that are associated with human nature, like being curious, being friendly, being fun-loving. These traits reflect inner life, vitality, and warmth, whereas uniquely humanness traits reflect civility and higher cognition and all of this. You could, if you deny these traits to other people, say, okay, I liken these people to animals, or I would liken them to machines. And this way we have a theory-based notion about what humanity essentially is. And of course we are also working with concepts like mind perception proposed by Kurt Gray and colleagues, and they ask things about, for instance, in the case of the robot here, they would ask, to what extent is the robot able to form intentions, to have inner life as well? So it basically goes in parallel to these notions of human nature and human uniqueness. There's also agency and there's experience that you could attribute to a human, but in our case also to a robot. So the idea is introducing these theoretical concepts to you. These are notions from the psychological or social psychological literature on dehumanization and intergroup processes. And when I jumped into this field of social robotics, which was not so long ago, I was wondering, what is anthropomorphism? Of course, I'm very well aware of your work, for instance, which is good. But I also found in other papers like that the notion of anthropomorphism is merely conceptualized in ways of, okay, this thing looks human-like. So the humanoid form was referenced here, rather than some psychological concepts behind this. So we were wondering, is humanity a continuum? Right now we have some findings by my PhD student Birte Schiffhauer, which questions these notions of humanity being a continuum. That means we could attribute humanity to humans or deny it, and at the same time we could also say, okay, a robot can be deemed human, and that would be my proposition. We could use the measures that I just presented to you also as proxies for anthropomorphism and address then the question of what makes robots particularly human. And of course, this is of importance for social robotics people, but also for the psychologists, because we know from previous research by Cliff Ness and colleagues that we treat machines just like we treat humans, and we do so quite automatically. But we need to know under what circumstances people do that, and what determines such perceptions and judgments about non-human entities. And so my belief is that by learning more about what drives anthropomorphic judgments from a psychological perspective, and I will tell you in a second what psychologists think about what anthropomorphism is, that understanding more about this will help us also understanding the underpinnings of dehumanization a bit more, because both these issues are hot topics in psychology that need further ideas and solutions. So the underlying rationale that we have, or the idea that I've been testing recently in my previous research, is the idea of psychological anthropomorphism, where we don't only look at, okay, what does this system look like? Does it look human-like? Does it look machine-like? That would be something that I found in many of the proceedings I've read when I started looking at the topic, but rather it is going beyond the merely observable behavior of some entity or some system or some animal or whatnot. Anthropomorphism entails that we would attribute, for instance, mind. You saw some items of the mind perception scale, or that we would attribute human nature, human uniqueness to a thing, even though this is not directly displayed in the interaction between human and machine. Or you would attribute emotions, inner states that might not be directly observable. And Epley and colleagues, they are not so much interested in if it's a cognitive error doing such things, but rather in the consequences of anthropomorphism. So they've proposed 3 factors, and I will walk you through these 3 factors by some empirical examples that we have gathered in my lab, where we have tested the 3 determinants of anthropomorphism, because essentially they propose 3 key factors: sociality motivation, affectance motivation, and elicited agent knowledge as the cognitive factor, to determine to what extent intentions, emotions, typically human traits are attributed to non-human things. And so what I find very important is really to point out, but I think I need not make that strong point so much here in this context, but nevertheless, I think we should have some theory. So I bring in some theoretical framework, which is the Epley framework of anthropomorphism, some theoretically based measures. And then, since I'm an experimental psychologist, I love to do experiments. So I will briefly introduce you to some very quick and simple experiments we've done, and I can talk to you later about more refined stuff we have also done, but I don't have so much time. So regarding the first factor, elicited agent knowledge, sounds odd to you maybe, but what it means essentially, this factor is the cognitive factor driving anthropomorphic inferences. That means when we are confronted with a robotic system or some unfamiliar technical entity, what would we do? We would draw upon our knowledge about fellow humans or ourselves, so anthropocentric knowledge, and we would use this anthropocentric knowledge in making judgments about this entity, just to reduce unfamiliarity and maybe anxiety also associated with such things. And so I want to give you some examples about elicited agent knowledge, and I will present you some example regarding the attribution of emotions, because that's what I started out with. And I told you about the effect that we would commonly associate more secondary emotions with the in-group or with with the in-group relative to an out-group, whereas no differences should occur for in-group and out-group regarding the attribution of primary emotion, which is commonly termed as the infrahumanization effect. You deem the out-group as lesser human. Layens would argue, oh, this is an intergroup phenomenon. You cannot test this in robots. But we did that. We showed people robots of the neck robot. I think you have it in your shelf as well. And this Korean android robot. And what we find here is that really this effect is not restricted to human groups only, but we find also that more secondary emotions, like the essentially human emotions, are attributed more to the humanoid. So elicited agent knowledge is triggered here to the humanoid robot relative to the more machine-like robot, whereas no differences are found for the primary emotions. So just for the social psychologists here, that's a kind of fun experiment. We find essentially the similar pattern using the Floby robot that we have at Bielefeld University, developed by Frank Hegel, and we don't find it so clearly there, but it's essentially the same. Humanoid robots elicit more elicited agent knowledge and are attributed more of these typically human secondary emotions. One other very interesting example that I want to give to you is the example that of a study that we did in the United States with white American participants, where we asked these white American participants to judge these more Afrocentric or in-group type of robot. We just gave them these pictures and asked them questions about mind perception. You've learned about mind perception from me before, so there are these subdimensions of agency and experience. And what is interesting is that at the very superficial level, participants would not produce this main effect of, oh, the in-group robot is preferred over the out-group robot, because maybe it might be due to concerns of social desirability and political correctness that they would rate the robot prototypes quite equally independent of their group membership. But then, as a social psychologist, I had modern racism in there and measured participants' level of prejudice towards blacks in America. And when you looked at that, then you would find that the highly prejudiced individuals would essentially attribute lesser agency and experience to the out-group robot compared to the in-group robot. So that is a point that I want to make here, is that we also should take into account measures that might, at the superficial level, not have anything to do with social robotics or the topic of interest, human-robot interaction, but rather be dispositional aspects that participants bring in, but they can clearly shape how they make subsequent judgments about these things. Because if we wouldn't have had that in our data, we would have just thought, okay, they don't produce this main effect, what can we do? You see, elicited agent knowledge here is also activated visually, as with the humanoid or non-humanoid or robot prototype before. We also did another very simple manipulation of social category and category membership in that study I did with Frank Hegel, which is in the Journal of Applied Social Psychology. Here, we made use of the modular industrial design of the robot prototype we have at Bielefeld, where you can simply change the robot's group membership by changing the hair length, which has not been done in robotics before. And from McRae and colleagues, we know that hair cues give us ideas about gender stereotypic knowledge structures. And these are activated, and subsequent judgments are then made if we do that in the human-human context. So, for instance, short hair would signify competence or agency, good for me this time, and long hair would activate gender stereotypical knowledge structures related to women. So we thought, maybe we could just, in a playful way, use that in robotics too, and test the assumption that also robot prototypes can be gendered. And of course, this has been done previously, but rather based on vocal cues, not on visual cues. And so this was the first work to test that. And what we find is what you can see here. It's pretty simple. But what you see is that people really attribute warmth and competence, the key dimensions of social cognition. So judgments that you quickly and directly make when you encounter people, that you attribute these dimensions of warmth and competence to a robot prototype as a function of the robot's gender. So the female prototype is perceived as more warm than the masculine prototype, whereas more competence is prescribed to the masculine prototype. So we basically find what we have found in human-human stereotypical judgments of male and female according to visual gender cues as well. But we didn't stop there. We also asked about task suitability of the robot and had pre-tested a lot of tasks regarding their gender stereotypicality. And when they were confronted with this masculine robot prototype, they would say, oh, it's more useful for typically male task like repairing something, providing security, and watching over things, controlling things, whereas the female one would be more of a care bot. At home, taking care of the children, preparing some meals as your personal assistive robot. So that's just another example where we really activated human stereotypes in the robotics scene. But we did that also on a very more subtle level, where we told participants, okay, you have to make judgments about a new robot prototype developed at Bielefeld University or developed at a Turkish university. And this robot prototype is called either Amin, typically German name, or Aman. So with this very subtle manipulation, we wanted to induce group membership and wanted to see whether people would indeed produce an effect called in-group bias, where you would favor your in-group and rate it more positively on very many dimensions, because that's happening when you usually judge people from in versus out groups. And would people even do that to robots? And I wouldn't be sitting here if that didn't happen. And it showed on these dimensions. I hope I can see it a bit at least. So regarding warmth, you can always see the blue bar here. It's the German robot prototype Armin, which was always favored over the Turkish outgroup robot Arman on perceptions of warmth, mind, behavioral intentions. Behavioral intentions entail, would you like to talk to this robot? Would you like to live with this robot? Would you like to get into interaction with the robot? Psychological closeness is a concept borrowed from Higgins and colleagues. Shared reality, how psychologically close do you feel to the robot? Would you like, or are you feeling like on the same wavelengths with it? And you see that participants all favored the in-group robot over the out-group robot, even at the level of design. And take note that they only saw the very same picture. They even thought that the design is more well, like we had formful ended, I don't know what this is, well designed, yeah? And this despite the very fact that all saw the same pictures. So what we find is essentially in-group bias at the robotic level, but you could argue, okay, this is because, or maybe you got it because Turkish people are not so well known for cognitive interaction technology or for robotics in general, so that produced your effect. So we thought to rule out this explanation of the social relevance embedded in these categories. We ran another study with my postdoc Dieter Kuchenbrand, and we told participants they would be doing a language test and a training for Asian languages, Japanese versus Chinese, and we really staged it cleverly. So we had lab rooms with labels blue and green, and unlike Turkish versus German, blue and green does not bear any social significance. So people believed, okay, I'm going to take this Asian language test versus the Chinese language test, and I'm part of the green group or the blue group. It's a minimal group paradigm, we call it in social psychology. And in the green group, they thought, okay, I'm taking the program that other fellow participants have taken before, so they are taking the same test, feeling, okay, I'm ostensibly in a group of fellow humans here. Whereas in the blue group, they thought, oh, some nows have done this program before, have tested this, and when we asked them then to rate now later on explicit measures, you find the very same effect that I've shown you in the German-Turkish context. Here's in-group bias visible again, where you would, when you believe that you're just broadly in the in-group with this now robot, even though you have not interacted with it, it's just bringing them into this psychological state, would make them attribute more competence, more warmth, more human-robot acceptance to it, and they would be, in the future, more willing to interact with it. So we found that, in the first place, quite interesting that it would also work in the minimal group paradigm, but we've also done some lexical decision task in that study, and those people who are interested in more of the indirect measures, we can discuss that later. When they were primed either with the now or a Dell tower in this lexical decision task, where they had to sit in front of the computer, get confronted with emotion words or non-words, and had to make the distinction, oh, is this an emotion or not? And they just had to push buttons. We measured their reaction times, and we found also that when the now was primed before an in-group was activated by means of the group membership that participants were allegedly in, they were quicker at recognizing secondary emotion terms as such. And remember, secondary emotions were the typically human emotions, so these were quicker on their mind. So we take this as some indirect measure of anthropomorphism here as well. So that's what I have to say regarding the elicited agent knowledge. I have many more studies, but we don't have such much time. I come to a fun other experiment where we also have at least 5 experiments with more refined paradigms like cyberball as well, but some simple experiments regarding sociality motivation I would like to introduce to you, because sociality motivation is what Epley and colleagues have deemed a motivational factor that contributes to the humanization of non-human entities. They would state, and you know it from anecdotal evidence probably as well, old grandmas or so, people who lack social networks, who are quite alone, who are lonely, they would attribute more humanity or talk to their computer or their pet as if they were a human. So that's what they essentially propose. So if you activate sociality motivation, so if you make people feel lonely, either by games like cyberball, which we tested, where you are left out at a computer ball game and feel excluded, or if you do it as simply as we did it, we just had participants write down episodes of their lives when they felt lonely, either lonely, socially connected, afraid, or rather neutral. So write down just a shopping experience. So when they did that, they had to really get into this feeling, immerse in it, and then write it down as well. And the idea was, when people are lonely, then they would attribute more humanity, measured with mind perception, human nature, human uniqueness. You know these concepts by now. And that is what we tested. And essentially, this is also what happened in the study that I conducted with Natalia Reich when she was still a master's student. So when people felt excluded and had to remember a lonely event, wrote it down, they would also attribute more humanity, measured by human nature attribution, human uniqueness attribution, and mind perception to the robots. And what is interesting is that my PhD student Birte Schiffhauer has also tested these factors that determine anthropomorphization, so humanization of non-human entities, when she used these factors in the intergroup context and has tested whether making people feel lonely would also reduce dehumanization. So does that work? It happened. People, after being made to feel very lonely, reported more human nature attribution to Turks versus Germans. So we could switch that effect around, and it's one endeavor that we are working on right now to really get a benefit for dehumanization research as well. So that's about the loneliness, but it worked with other manipulations of loneliness as well. And we also took into account, and it's some point that I will not raise here today, but Epley and colleagues have only proposed these 3 factors, have in the beginning not done much empirical work on this, and have proposed, okay, there are some dispositional aspects of all these components as well that you should measure and work on. We have done that in our lab as well, and I can give you at least some papers where you can read about this, because I find it important not only to look at the situational aspects that can activate certain state of minds, but also the dispositions people bring in. For instance, we measured loneliness using the UCLA loneliness scale, or regarding affectance motivation, for instance, which I will talk about next. We measured a desire for control, which is a correlate of affectance motivation. And affectance motivation ultimately is perceived as, our motivation to interact competently with other social interactions. So we want to make sense of the world around us, and of course we also want to make sense of the world around us when we deal with some non-human entities. And if people are not familiar with Now or other robot prototypes, they might feel insecure, they might feel a bit anxious, and this could raise their affectance motivation, their desire to master the situation efficiently. And this was proposed, that affectance motivation would raise anthropomorphic inferences, and we tested that in a study where we told our participants, all right, you poor thing have to go to our lab now, you have to meet or not meet with this robot prototype Floby, and they read a bit about what he could do, what he is capable of, what his functions are. So it's a social robot that can move around freely, it could recognize you, and all of this. So that's just the information everyone received when they came into our lab. But then, importantly, we manipulated affectance motivation in two ways. We told them either you have to do a task with this robot, and you have to do it together. It's object recognition. You have to fulfill this task, or you have to do it on your own. So in this condition where they felt like, oh, I have to do it on my own, great. I don't feel so nervous. It's not so anxiety provoking. Good. But the other ones that thought, okay, I have to deal with the robot now. Oh my God, how am I going to do it? Affectance motivation should go up, and specifically so when they also would get the idea, oh, this robot even functions at a random principle, because that would make these judgments even stronger. And we manipulated by telling them that the robot would move and function at a regular principle or just at random, so you would never know what to expect, you know, and that should raise their affectance motivation and subsequently also their anthropomorphic judgments. At least that's what Epley and colleagues would predict. They had only in their previous work looked at predictability of dog behavior, for instance, with unpredictable dogs being anthropomorphized more by just asking them three questions. Does the dog have emotions, a personality, or free will? Which is not very fine-grained. So we asked participants about human nature and human uniqueness attribution again, and this is what you see here in the very small graphs. We also asked them about acceptance of HRI, and the patterns of results are essentially always the same. Predictability, unlike in previous work by Epley and colleagues, did not increase the anthropomorphic inferences per se, but when it became socially important, so when they had the idea, I have to do this object recognition task together with others, then they anthropomorphized the robot to a greater extent. I hope you can see it, otherwise you... so it is... Well, I have to bend around here a bit. So this is a predictability high versus low as a function of anticipation of the human-robot interaction. So here when you see the black line going up very much, that's at the level where it's a lowly predictable robot, but when participants anticipate they have to do something with it, they would attribute more humanity to it. Maybe to just feel more secure with the whole situation. We did the same paradigm again with the now robot to see whether it would replicate. It did. We also measured desire of control as a dispositional variable, and also had participants interact briefly before the whole situation to see whether this might be needed to kind of strengthen the judgments, and we got essentially the same findings that you can read in the 2011 paper. What I find very interesting is another way of looking at predictability, and we did a study together with Maha Salem using the Ashimo robot, and the Ashimo robot was used as a helper in a context of moving. So participants were told, okay, you are now in this kitchen environment, and you just moved into this kitchen environment, which you can see on the picture here. I cannot show you any graphs or so because Honda is quite restrictive with all the data and stuff. But what we had the Ashimo robot do is use gesturing behavior and to use actual human gesturing behavior in a more consistent or inconsistent way. So sometimes the Ashimo would say, put the bowl onto the left top shelf and point to the right, or would point down. So it would make a mistake, would be essentially a bit unpredictable in its behavior compared to a control condition where it would do all the 11 trials in a correct manner. And we found that when the Ashimo was used as such a helper, that this multimodal, particularly incongruent communication behavior would increase human nature attribution, warmth attribution. They would feel more psychologically close to the robot and report more contact intentions. So that is basically in the similar line of findings as the Floby studies we have done, just with another platform again. And speaking of gesturing, we have also done gesturing research with virtual agents in the collaboration with Stefan Kopp and his group, Sociable Agents group in Bielefeld. And so what makes machines particularly human could also be human-like conversational behaviors. So what we had participants do is to sit in front of a large screen, as you can see in the photo there, and participants had to listen to the virtual agent Max in describing such a scenario over there. So he was describing this either using gesturing or gesturing and gaze behavior, and we were also interested, I mean, that's my colleague Kirsten Bergmann who did that study. She's interested in gesturing behavior and whether actual human-like gesturing tracked with lichens would be, whether we should use pooled gesturing data or gesturing data from individuals. So that's a technological stance. For me as a social psychologist, it's not so much of a matter. I'm just interested in, okay, would this shape the social perception if we implement such functionality in these things, or could he just go on and talk about the scenario that is depicted in the picture without any gazing behavior, which is typically human? I look at you as well, or if I gesture a bit, would that change your social perception of a human as it does, or of a virtual agent as well? And what you can see is, yes, it does. Only for competence, it didn't change the ratings, but that's okay. What I find quite interesting is that when the virtual agents was using gesturing and gaze behavior, participants would attribute a higher theory of mind to the robot and would say, okay, he knows much better what he is talking about. You know, they had this feeling. Also, they had the feeling that they themselves would be able to memorize much better what he had all been saying. But when we looked at the objective data, like what did they draw when they had to reproduce the scenario, or what features did they remember, they screwed up. You know, it did not improve their actual performance. It just improved their subjective feeling of how they could perform. And I think that's what we also should take into account. And so gesturing behavior, as said, is something that makes us human too, or that characterizes us as human. And so does emotion display. So what you see here is this, well, I'll stop this maybe for a second and give you some background. What you see here is a study that looked at emotion display with the iCat, which is very simple, and you know the iCat by heart, I guess, inside and out. But what we were interested in is whether when the iCat displayed contingent emotional reactions in front of the users, that we would assume this would raise anthropomorphic inferences about this thing, and not only about the emotions that are well observable, which would be primary emotions, because the iCat cannot do shame or admiration or hope or guilt, but it could show happiness, joy, anger, and anxiety. That's what it did in that study, because we had participants sit in front of the iCat and read Little Red Riding Hood to it. So we asked them, please read this as vital as you can with emotional expression, because we want to test the language comprehension system. So please read the fairy tale sentence by sentence, and then please look what the iCat is doing, and finally provide your judgments. So that's what they did, and that's what I will show you. I will just go back and start this again. It's in German language, I'm sorry, but it's Little Red Riding Hood. Nobody, everyone will know. And look at the iCat. Hopefully, can. Time? Yes, I'm done soon. So just blinking in the neutral condition, it would just blink, look down at the participant script, or show signs of vitality as compared to emotional reactions. So the wolf is going with the little girl, and then she's picking flowers, and the wolf had grandma for lunch. I think that's what you got. it's very scared. So that's the contingent condition. And as I said, would this emotional reaction that is contingent with what was read to the iCat change judgments? I'm sorry I have to cut this, but Christoph gave me the timeout sign. What happens here is essentially on most of the dimensions you can see here, when the iCat reacted emotionally contingent, they would not only attribute more primary emotions, I mean, that's what she showed, but also secondary emotions, human nature, intentionality. They would feel more closer to it, like think the robot is more likable, and they would enjoy human-robot interaction more, which is not surprisingly so, but we find this effect on all of these dimensions. So the robot is anthropomorphized to a stronger extent when emotion display is also shown. And I would have analogous findings with virtual agents for you as well, but in shortage of time, I will come to my conclusion and will make the point that yes, it's good to have some theoretical framework, but it's even better if you test it thoroughly, if you not only take into account situational aspects of the factors that are at play, but also take into account the dispositional ones. I can assure you we have done that, and we're pretty much done in tackling or tearing apart this whole model, and we'll look at cultural aspects more strongly so, because that's also proposed but not tested yet, and we do so with colleagues at Osaka University and have run some studies with colleagues at Eindhoven as well. And as I pointed to earlier on, we also now test the factors of elicited agent knowledge, sociality, motivation, effectiveness motivation in the human intergroup context to reduce prejudice and dehumanizations to social outgroups. And we have had quite some success in doing so. So these factors can also inform us from this social psychological stance and help us reduce such negative outcomes in the intergroup context. So other open issues or things that are of interest to me is also to look at long-term interactions, and we now have a smart home environment at Bielefeld University as well, where we can look at human-robot interaction with many platforms, not only the Now or the Floby, but also a Mechabot that we just got. And I'm interested in minor morality attribution as well, and have run some studies there. Two of my PhD students are working also on imagined contact to facilitate human-robot interaction, to prepare people essentially for a real interaction. And we have also had some success in showing that imagining a positive contact with a robot would change attitudes towards the robot at the explicit level. And we are working on implicit measures of anthropomorphism quite extensively, also using the SMP or the IAT or priming tasks to broaden the repertoire of measures, and have also tried to look at neural correlates using physiological measures also as well, but that's rather confusing data that we get here, so it's harder to really get to a point there. And a slide that I will skip, that I brought for you, Jürgen, is the semantic misattribution task. We have done that to measure dehumanization and anthropomorphism, but we can discuss that later on. And before that, I will let you other guys go. And thank you very much for your attention and for being here. So I'm open for questions. So do you still have questions, or those of you who don't have to run off? Yeah, I know, I'm sorry. Tons of stuff, I know.
Yeah, I was thinking, anthropomorphism is related with reciprocity, and particularly this experiment as the gender of the robot matters. It's interesting. I don't know exactly how could be applied, because I guess there are not a regular taxonomy of the robots, right? They are quite different.
Yes.
From them. So
yes.
What kind of reference can you have in order to establish these parameters?
Yeah. So So the good thing at Bielefeld was that I had the robot Floby available, which you can play around with the features, you know, and that makes it so unique in testing it or using it as an experimental platform. Because as you said, many robots are just prefabricated, or like when we use the Now in gender research, we have a paper out there as well. We called the Now Nera or Nero and gave it a gendered voice, tested that, or we had a gender neutral Floby, for instance, without any hair, like a bald guy, but speaking in a female or male voice, robotic or human voice. And we found there as well that when you use the human voice of the participant's gender, so a female voice with the female participant, they would project humanity, mind perception, psychological closeness, warmth, all to the same-sex robot. So they would attribute more of it to their same-sex robot than to the opposite-sex robot. So I've some slides I can show you later. But that is, yeah, so you don't need to have the visual cues, but I use them here because it was just, possible, basically, to play around with their judgments. But
I remember well, in the experiment that we did here about reciprocity, we used both agents, but both of them look pretty much male.
Yeah, yeah.
So we tried to find some data about the gender of the people.
Yes.
And we didn't find significant differences. You know, male and female were pretty much the same reciprocal attitude towards them.
Okay.
Yeah, but the robot essentially
was one gender.
Any voice or any
ultimate
interaction.
Yeah. But so as simple as my points, or as basic as my points are, I would just want to stress that these simple details can change our perceptions of these, even of these machines, and produce analogous effects that we commonly only find in human perception and judgment in social cognition research. Yeah.
Have you looked into any of the generally speaking, when you debrief your participants, are they able to describe why or give reasons for the attributions they make, or do the attributions just happen automatically and without their knowledge?
So what Epley would also propose in their framework, it's an automatic process, and also colleagues from Eindhoven have some data on the automaticity of that process, or what you can see also in our reaction time-based data. Yeah, it happens pretty quickly, automatically, without their conscious evaluation. But we also measure individual differences in the tendency to anthropomorphize in our participants as a dispositional variable to kind of disentangle, okay, these are the high anthropomorphizers, they are from their disposition more likely to attribute humanity to nature, technology, or to animals. And when you take this as a covariate or a control variable, you can nicely have even more clearer data patterns. You know, it really helps to look at people who naturally see such things in non-human things. I would also be surprised, but now I've done so many studies with all these measures of dehumanization or humanization, like mind attribution or human nature, human uniqueness, and they don't produce floor effects. You know, they really use the scale, and the psychometric qualities of these scales is across studies quite good. So we can really use them as measures of humanization as well. Mm-hmm.
I saw you made some studies with robots and some with pictures of robots.
Mm-hmm.
I know there are some papers out there, but did you, from your experience, is there a big difference between them? I mean, is it fine if you don't have a direct interaction like with the robot? Is it okay to just use an avatar, or is it big difference if you have an avatar or a robot? Do you have any experience?
There's research, of course, out about embodiment of these systems. We haven't systematically addressed this in our research, but sometimes I had to use the pictures because the Floby robot was just not available, because it's a research platform. You know, it's not just there at our hands to run the study with. Or if you imagine I would do such a study, it takes like half an hour maybe for the participants to run through it. But then the system heats up, you know. It's just not functional for an 8-hour run-off experiments in the afternoon, you know? So I had to kind of use video materials sometimes or picture materials, but when I, for instance, once compared effects of human-human dehumanization versus the robot effects that I have, or the stereotype effects that I have, then it's at equal level, you know? So just having a picture doesn't really reduce the attribution of humanity to the robots. So it seems to be equally good, but I would always prefer human-robot interaction if I can do it in a controlled setting. Yeah, maybe not in a field setting so much. Yeah.
It's obviously quite good if you want to scale it, or so you want to try it somewhere else in other countries.
Yeah.
You could use pictures.
Yes, and videos.
Way easier and faster.
Yeah. Thank you.
All right, thank you very much then.
Yeah, thank you. So I'm here.